Hello friends, so today I'm gonna solve this problem, minimum number of pushes to type a word. So you guys remember before smartphone era, we have this kind of mobile phones, right? So if we want to if we want to type C, we used to press this keyboard 3 times, right? So similar kind of keyboard is given to us, and then we are given one word which we have to basically print. So it's about that what would be the minimum number of pressing operation to type that word. This is what we have to do in this question. But now we have one thing here that we are having a liberty to change this keyboard. So basically changing means we can do the remapping. Basically we can put like ABCs written over here. But for our operations, to make it minimum number of operation to type that word, we can modify these mappings, right? We can make it like ABC, instead of ABC we can put it CBA, whatever it is required according to our input. Okay, so for example, let's take a simple way that how would be typing, let's say, suppose we are typing BE. Okay, so how many operations would be required? So see here, to print B, we need to press this guy 2 times because B is the second character. So 2 operations would be there to print the B. Basically, operation means the pressing of this keyboard. And come here to press to type E. Here we need the 2 times, right? So it would be 2 plus 2, 4, right? 4 time pressing would be required for this keyboard. Now let's say this is something like BF, right? So if BF is the word, so in this case, how many operations would be required? So for B it required 2 and for F it required 3. So total 2 plus 3, 5 operations would be required. But as in the question it is said that we have a liberty to modify this. Okay, so let's say take this example BF. Here it is taking 5 pressing operations. But what if I do few things? Let's say instead of instead of A, I write B first. Okay, so this will become BAC, right? And similarly, here I type it FDE, okay, or FDE, FED or FDE. So now how many operations it would take to print BF? One operation to B and similarly one operation to F. Now how many operations are? Only 2, right? So we have to do our keyboard mapping in such a way so that we will get the minimum number of operation to print any word. Okay, this is what we have to do. Now we will talk about what would be my intuition. So let me go with a diagram for more clarification. Yeah, and one more thing is here we have only these 8 buttons are there only. This button very first and the last 3 are not there. We cannot touch them. So we have only these 8 buttons. So all the characters of alphabet, all the 26 characters we have to accommodate in these 8 buttons only. Now how we would do to make it in such a way that it would take the minimum number of operations. So my intuition would be, so for example, this is our word and we have to find the minimum number of operations. So see here there are 3 distinct characters, right? B, C and D. And B came 4 times, C came 3 times and D came 3 times, right? But we have 8 buttons. That means we want to take every guy to print in single operation, right? So if I put something like this, I put B here and then I put C here and let's say D here. Okay. Now remaining characters we can put like this. Okay. Any characters. There are we have 23 more characters, right? So I'm not interested. We can put anywhere like this. So what I mean to say is here, let's say it could be something like B, L, K, anything, right? But we are interested to put the first position of this character, right? So now what we can do to type this word, what will happen? Because this guy is available at very first. So it will take 1 operation to print single B. That means 4 operation to print 4B. So 4 operation for B because it is at very first character. Similarly for C, see here we will press this guy because C is at very first. So this will also take 3 operations. Okay, 1 operation for every character. And now come to D. So here this is our D. So D. So there are 3D, right? So 3 times operation. So this would be our 10 operations we can print it. Now this is a favorite case. Now think about a situation when we have more than 8 keywords, right? More than 8 distinct characters. Let's take an example. Okay, then it will make better sense. So suppose this time we have a string like this. Okay, this is a long string which has so many characters. Then first of all we will find the frequency of all of them. Then we will decide what would be our next step. Okay, the frequencies of the characters would be something like this. So see here, these are the frequency count of it. S came 22, D came 12, like that. Okay, so now we have, see here, we have 9 different characters, right? Okay, so these 9 different characters cannot accommodate by these 8 things, right? So first 8 we can put directly to the keyboard as a first character, but at least one guy would be there which has to become the second character in any one of them, right? So it would be something like, we can put it like S, so starting with S, so we can put S as first character. Then we have D, so D also we can put. Then we have T, so we can put T also first character. Similarly L also first character. We can put A also first character, B also first character, and M also first character, right? And then even P also we can put as a first character. But then comes this guy N, right? N is the 9th character, so this cannot become first character, so we have to accommodate it somewhere. So let's say we can make it like this. So now what will happen, all those first 8 characters we have to put them in such a way that frequency is from top to down. Okay, so first the most frequent guy should be on the top, right? And till 8 we can put till 8 all the top down or top frequency to decreasing order we can put the into these buttons, right? But when it comes to 9 and more, in that case they have to become either second character. If all of them are filled, then they have to become third character, right? So in this way what will happen, we will minimize the number of operations. So see here, if there are 22 S, that means we can single press, we can write S. So that means 22 operations to write the 22 S in this character, right? And similarly for D we need 12, right? For everything we need whatever number frequency there till 8. But come to this N, for N we have to press to single, you see here, to print the single N we have to print it 2 times, right? So for to print 2 characters we have to do how many times? It would be plus 2 into 2, because to print single character we need 2 operations and we have 2N, right? So this would be 2 into 2 and so on. If let's say for first 8 we will get the single press. For next 8 we will have to press 2 times. For next 8 it would be 3 times, right? And for next 3, right, we have 26 characters. So till 24 we are fine, we will increase 1, 1, 1. But for last 3 characters, whatever it would be according to the frequency, that would be taken the 4th frequency. Okay, so in this way what will we do? First we will get the frequency of whatever character we have got, and then those frequencies we have to tag in the decreasing order. Okay, and then first 8 we have to tag the only single press, and similarly we have to proceed ahead. Now I will write down the pseudo code of my algorithm, my approach, which would be O of n. Even there is a sorting, but still I am not going to the n log n. I would be solving it in O of n. So let me write down my algorithmic way. So see here, this is my code snapshot. So first of all, what I am doing, I'm just creating one integer frequency array of 26 size. Okay, because we have only 26 characters. Okay, so first of all, what I will do, I will take the frequency of all the characters using one for loop through this word. Okay, so suppose till here we got the all frequency in this frequency array. Then what we will do, we will sort it. Okay, sort all those frequency regardless where what character came, but we will get the. So now what will happen once we sort, on the last location we would have the highest frequency count, right? And similarly it would be decreasing. So we are coming from the back. Okay, from the last location we are coming towards the 0th index, right? So what we are doing here, so while k is greater than or equal to 0 and frequency k should be greater than 0. Now see here, from the starting from the very last location till 8th, basically from 25th to 18th index, right? There would be total 8 characters, right? So first 8 characters, what we are doing, look at here, we are just summing. Okay, moves equal to moves plus frequency. So whatever frequency came, like let's say as in this previous example, s came 22 times, right? So that was the highest guy. So for that s we have to make only single press, right? So that means whatever number of moves are there, only that would be added. Okay, so I am doing just move equal to move plus frequency k if the index is between 25 to 18. Okay, so that means most highest characters having the highest frequency, first 8 characters we are adding as it is. Now come to the second phase. If let's say they are not the top 8 but the second tier, means they are coming from index 17 to 10. Okay, basically the next 8 in the decreasing frequency way. So next 8 guy would be having, for example, this n is falling in the next 8 guy, because first 8 anyway getting the first place in these keyboard, but we have because only 8. So for next 8 we have to put on the second place, right? Like n is be placed here. So for second tier guy we are doing moves equal to moves plus 2 into frequency, because anybody who is sitting on second location, we need 2 press operation to print single time, right? So for that reason I am doing 2 into frequency. Now we have the last set, another set of 8 characters, okay, which has the further down decreasing frequencies. Okay, so for those are the guys which are residing third in this keyboard. So let's say for SNE, let's say there was one more character SNE which is falling at third location. So to print this guy, how many operations? We need the 3 operations because it is residing at third location. So for that reason what I am doing here is moves equal to moves plus 3 into frequency of k. Okay. Otherwise we have, see, by 8 8 8 we can cover the 24 characters, right? But we have 26 characters. Okay, so remaining 2 more characters are there which will go to this in else loop, right? And for in else, let's say at some keyboard we have something like A B C D Z, right? A B C D Z. So how many times Z would take to, how many operations would require to print a single Z? In this case it required 4, right? So that is why in else case I am doing moves equal to moves plus 4 into frequency of k. Okay, so finally after doing this frequency thing we would have the total count of moves. Okay, then we would returning our total number of moves. Okay, so let's do a simple dry run with one example. So see here, for example, this is our string world. Okay, and I have highlighted the their frequency, right? For example, this is the frequency we came. So first 8 guys we have to look 1 2 3 4 5 6 7 8, right? So if somebody asks us design the remapping of that keyboard, how would we do? So we would have like 8 keyboard, right? We have only 8 buttons. So how would we put that 8 buttons? So first 8 guys would be go to the first place of all of them. Okay, so see here we would be very first. Okay, so here we can put V. Okay, here, so first guy we can put here. Now come to this guy Z we can put here. Okay, then we can put P here, and let me make it a bit smaller, so P can put here. Then see here we have A, so A also can be put like that, only we can put A. Then we have B, then we have R, right? Then we have Y, and then we have W. Okay, so till here we are having all those characters which are highest in the frequency, top 8 highest frequency. Okay, then we are looking for the next guy. So again G. So G should become the second guy, because anyway we need the 2 press for this. So G should be come like this. Now come to T. So should we place T here or at here? Obviously here, because we want the 2 press, minimum press. So we can put Z and T here like this. Now come to D. Similarly this T also should be the second guy. Okay. Now we have M finally. So M also should be second guy only. Now consider some other values, right? We can, I'm not writing this string, this would be very long string, but consider we have another set of such kind of characters, right? Because anyway we have 26 characters. So till 8 we can again accommodate the second place, right? Anywhere we have the second place, 8 places, right? So for those 8 places we would have the 2 operation. Now let's say we have another set of 8 places, then we have the third location, right? So we have the 8 places to fill the third location. Okay, so now suppose we are also filled with the third location also, so we can go in this way, 8 into 3. So basically till the 24 different characters we can accommodate in the first 3 guys, right? So but we have the characters equal to 26, so remaining 2 has to become the fourth character, right? So 4 operations. So for that reason I have written this if condition, that if we are on first tier of 8 guys, then we are not multiplying, we are just adding the frequencies. If we are in the second tier, like this second tier, all these second tier guys, let's say G, we need 2 operations to print G, so that is why I am multiplying with the 2 here. Then we have the third tier of 8 guys, so here I am multiplying with the 3, all those here, just like this. Let's say we have V, G, L. So L is third tier. So here we need 3 operations. So that is why I am making the 3 into frequency. Otherwise, there could be some case like we would have something like B, P, L and Z. So in this case, if we want to print Z, how many operations? 4 operations would be required. So that is why for L's case, we are making the 4 into frequency. And finally, our moves would be the answer. So this is what my approach. It is taking often time. And one more thing is, though we are sorting here, but some of you might say that this is n log n, but see, we have 26 characters only, right? So if we doing the 26 character sorting every time, it would be n log n, which is 26 log 26, which is a constant number. Okay, so this would be always constant. So don't get confused with the sorting algorithm that it would take n log n. No, it would take n only, because we have this is constant. So this is even O of 1, not even n. Okay, so this is constant. Now let me show you my code. And okay, see, this is anyway same code what we were doing here. I created the frequency array, then I am finding the frequency of all the characters in the word, then here I am sorting my array. Okay, and then here see, I am starting from k equal to 25, basically the last character which having the highest frequency. Okay, so this is the tier 1 of the 8 characters, which would be required only frequency, and similarly for tier 2 multiplying 2, for tier 3 I am multiplying by 3, and else I am multiplying by 4, the 4 characters, right? So this is the way, and finally my moves would be the answer. So let me run the code. Yeah, it is running. Let me submit as well. Yeah, so it is 100% faster. So thank you for watching the video. If you guys have any concern, please make a comment over there. Thank you.